as I mentioned earlier, the field and charging circuits share a common path to the ammeter. But from the ammeter, the charging circuit goes back through the bulkhead connector to the alternator output terminal and ground.
Right here, I'd like to point out that the car ammeter does not indicate alternator output. It only indicates current flow in or out of the battery. When the battery is fully charged, it's normal for the ammeter to show only a slight charge.
A good point, Tech. And current flow in the charging system itself is always from the alternator to the battery. Current flow from the battery to the alternator is prevented by the rectifiers. For this reason, we make the charging circuit resistance test with the engine running and the alternator charging. The charging current must be controlled or the voltage drop indications will be misleading. Therefore, we will cut out the voltage regulator and control the current output by adjusting engine speed. Now, since the entire charging circuit is hot, always disconnect the battery ground cable before setting up for the circuit test. If the output terminal or wire is accidentally grounded, the charging system or the test equipment can be badly damaged. For the test, connect a test ammeter in series between the alternator output terminal and the charging circuit wire. Then disconnect the field wire at the alternator and connect a jumper between the output terminal and the field terminal. Also, disconnect the regulator ignition wire. The jumper between the output and field terminals completes the test ammeter circuit to ground through the brushes, slip rings, and rotor winding when the battery cable is reconnected.
With the rotor standing still, a field current draw of less than 2 amps indicates high resistance inside the alternator, possibly caused by worn brushes, bad slip rings, or a poor ground at the alternator frame. If the reading is more than 3.5 amps, it means you may find an internal short in the insulated brush lead or in the rotor winding. Now back to you, Larry.
Okay, Tech. If the alternator field circuit resistance checks out, we can complete our charging circuit test hookup. Connect the positive voltmeter lead to the charging circuit wire along with the ammeter lead. Clip the negative voltmeter lead to the positive battery post. Start the engine and adjust the speed to get 10 amperes on the test meter. The voltage drop should not be more than 0.3 of a volt. If the drop is higher, you'll have to check all circuit connections.
If resistance in both the field and the charging circuit is okay, you're ready for the alternator output test. The test specs call for a specific current output at a specific speed.
Right, Tech. For the output test, the voltmeter is connected across the circuit to the charging circuit wire and ground. The regulator remains disconnected from the circuit, and we leave the test ammeter and the field jumper connected, as in the previous test. Connect a carbon pile across the battery to provide an adjustable load, so we can maintain the voltage specified for the output test. Adjust engine speed to exactly 1250, and load the battery with the carbon pile to get exactly 15 volts on the voltmeter. Then read the current output. Be sure to remove the carbon pile load from the battery as soon as the test is completed.
The engine speed and voltage specs are the same for all of our alternators, but the current output is not. Your service manual gives you the right current output specs for the alternator you're testing.
What if the current output isn't within specs?
You'll have to remove the alternator for a bench check. Right now, we're ready for the voltage regulator test. For the voltage regulator test, we first remove the field jumper and reconnect the regulator field wire to the alternator field terminal. We also reconnect the wire removed from the regulator ignition terminal. In addition, the positive voltmeter lead is moved to the ignition terminal of the regulator. We leave the ammeter and carbon pile connected as in the current output test, but the carbon pile is turned off during the warm-up before the test. Start the engine and again adjust the speed to 1250. Load the system by turning on lights or accessories until the test ammeter shows 15 amps. Then run the engine long enough to warm up the charging system.
Do you have to run the engine for 15 minutes like the manual specifies?
Yep, you sure do. The voltage regulator was out of the circuit during the other tests, and it's relatively cold. The regulator is temperature sensitive, so the charging voltage varies during warm-up, but stabilizes at normal operating temperature. In the specs, you'll notice that charging voltage depends on regulator temperature. measured 2 inches from the regulator cover after the warm-up. Remember that the cover must be in place for all regulator tests. And one more thing. Be sure to cycle the regulator before you take each test reading. The easiest way to do this is with a handy little cycling switch you can make for yourself. The service manual tells you how. Want to take it from here, Larry?
Ready and waiting, Tech. The first part of the test checks voltage control with the regulator operating on the upper contact. This is the normal condition when the charging system is carrying a high electrical load at relatively low speeds. Recheck the engine speed to make sure it is at 1250 and adjust the carbon pile to maintain the specified 15 amps. Then check the voltage and regulator temperature against the specifications. If you find that the voltage is higher than the maximum spec, armature spring tension is probably too high. After adjustment, be sure to replace the cover and cycle the regulator before retesting. When you find the voltage below the minimum specification, armature spring tension is most likely too low. If the voltage indication is within the spec limits, you can then go on to the second part of the regulator test. For this part of the test, you raise the engine speed to 2200, turn off the lights and accessories, and adjust the carbon pile load to reduce the current from 15 to 7 amps. After you cycle the regulator, the voltage should be at least 0.2, but not more than 0.7 of a volt higher than in the first step. If the voltage is within limits, the regulator is working properly and the testing job is finished.
Hey, suppose the voltage is higher or lower. What then?
If the voltage doesn't meet the specs on this test, either the point gap or the air gap is probably incorrect.
What's the reason for the fusible wires in the voltage regulator?
The upper contact fuse wire protects the field circuit, especially against the short to ground in the field wire to the alternator or in the rotor part of the circuit. If the upper contact fuse wire is burned out, you'll get no output in the first part of the voltage regulator test. With the fuse open, you lose the part of the circuit that supplies high alternator field current to produce full alternator output. On the other hand, high output in the second part of the regulator test could mean an open lower contact fuse wire. And that's my story on charging system diagnosis, unless you have some questions.
Just one, Larry. When are you going to give me a lesson on the new insulated brush alternator and the electronic voltage regulator?
It just so happens that this month's handy-dandy reference book includes detailed instructions for testing the new alternator and regulator. However, we can take a minute or two right now to explain why the test hookup for these new charging system units is different. How about it, Larry?
Sure thing, Tech. In the first place, in a conventional system with electromechanical voltage control, the regulator is connected into the field circuit between the insulated field brush of the alternator and the positive battery post. The grounded brush completes the field circuit to ground. In the new insulated brush alternator, both brushes are insulated. The former ground brush is now an insulated positive brush which connects directly to the rectifier heatsink. This means there is always a direct connection between the positive brush and the positive terminal of the battery. The new electronic regulator is connected to the field brush, but this has become the ground side of the field circuit. In other words, the new regulator is still in series with the rotor, but it's now in the negative side of the field circuit instead of the positive side.
And that's why the two types of alternators and regulators are not interchangeable. Also, when checking the new system, the jumper used in the current output test is connected from the field terminal to ground, instead of connecting it between the field terminal and the output terminal. Of course, the new regulator can't be adjusted or repaired, so servicing and testing that part of the charging system is greatly simplified. You can test regulator operation without a warm-up, and you'll find that complete system testing is also simpler. And now, this is where we all thank Larry and Bill for giving us a new slant on charging circuit diagnosis. Be sure to read about the new alternator and regulator in your reference books, and use your service manuals and service bulletins. See you all at the next meeting.